So as many of you know, I host a whole bunch of stuff under the Sineware umbrella, like a Mastodon server, Matrix server, Git instance, and a whole bunch of other stuff, as well as all the infrastructure for my work in progress Linux distribution, Pro Linux. And of course, one of the things that makes Sineware services unique is we run all the servers ourselves. Now, one of the biggest difficulties of doing that compared to using something like a cloud provider is, of course, maintaining uptime reliability. Now, of course, one of the sources of unreliability with our services, or really for anything that you try to self-host, is going to be internet connection, since that is a single point of failure. So today we're going to be setting up a failover LTE WAN situation. So I got a brand new SIM card from a new mobile provider here in Canada that's quite a bit cheaper than the rest and has a couple of features that are particularly useful for us, not sponsored by the way. And we have a LTE router, so we're going to be doing an unboxing of this. So we're going to set this up, and we're going to be setting up a failover WAN setup on our OpenWRT router that all of the servers are set up on, and we'll see how that works. Hopefully, the idea is that if the main internet connection ever goes down, or if it becomes unreliable or something like that, we can pretty much seamlessly fail over to the LTE connection, hopefully without even breaking active TCP connections. So let's get started. I guess we'll start off with the more boring thing here. This is the FizzMobile SIM card I ordered. FizzMobile is a new mobile carrier. You probably have heard that Canadian LTE mobile prices, 5G, it's pretty expensive. FizzMobile is sort of a new provider. It's actually a flanker brand of Freedom Mobile. What makes Fizz unique, or at least good for my situation, is one, the monthly rate is cheap, but the reason the monthly rate is cheap is because we can actually customize the plans pretty hard to basically just turn off calling support, texting support, and even nationwide coverage, since we really don't need any of that. We just need a little bit of data. In any case, let's see what this unboxing is like. We've got to pull the tab. And here we go, activate your SIM card, and I'm assuming in here we just have the SIM. I'm wondering if it comes with an adapter, although we're not gonna need that. Yes, it does. It's the standard kind of pop-out thing. We get a little SIM tool, which is very nice. This is just stuck on with that kind of classic card glue gel. I also just realized I'm gonna make life a lot harder for myself by the fact that I needed to blur that activation number. Anyway, so that is the SIM card. I'll take this away. All right, now for the more interesting part of this unboxing. This is the Teltonika RUT241. You'll see very shortly in here. And this is basically just a pretty basic industrial style LTE router. It has a bunch of features built in. Here we have the RUT241 quick start guide. Feel free to get that QR code. And we have all of the device specifications. It does have Wi-Fi and stuff built in as well, so that'd be kind of nice, I guess, as an additional management Wi-Fi or something like that. It supports 4G LTE, not 5G, although Fizz I don't think will give us 5G. So put that to the side. We got our nice big mobile antennas, single Wi-Fi antenna. This thing is not super fast. It's only Cat 4 LTE, so only I think a maximum speed of 150 down and 50 up. The actual Ethernet ports on the RUT are 10100. Here's our Cat 5e patch cord and the RUT itself. This is it. I mean, metal case, comes in a form factor. There are adapters. You can DIN rail mount this and all that kind of stuff. There are your antenna ports, your 10100 Ethernet ports, the SIM card slot, which is right there, and then the SIM eject hole. And this, again, very industrial style power adapter. I believe this also has two kind of GPIO digital I/O pins, so that's kind of nice. And of course the power adapter with that same Sineware style power adapter. SIM adapter kit, which we won't need since our SIM card already comes in the larger SIM format. Okay, so this is probably the plan I'll go with initially. It's very small, just 6 gigs of data. Ontario only coverage, pretty much everything turned off, no texting, no calling, because of course we're not going to need that. Although technically texting I could use through the RUT. It has some configuration for remote management over text or whatever, but we don't need that. That'll give us $15 a month, which is probably extremely expensive for this kind of plan where you live, but in Canada this is absolutely incredible. This is what we will go with. Of course, phone number wise, again, totally doesn't matter, but I'll pick something random. It's possible maybe I'll use this for something else in the future as well, so we can, I'll pick a number. I'll refresh this list, so don't try these numbers. SIM card plan is activated. Well, at least soon activated. So we should be good to install this in the RUT and get that all set up. Alright, let's get the SIM card installed in the RUT itself. Step one is we're going to need the little tiny SIM eject tool. Just pop out the SIM card tray. There we go. So we should just be able to grab our SIM card, pop out the largest SIM, which I believe is what, mini SIM, like that. There we go, and just insert it in there. Alright, so theoretically that should just perfectly click into place. Perfect. Let's stick that in. There we go. That is SIM card installed. So next step are the antennas. So, and of course the antenna situation, there are two of these sort of wider, flatter, larger mobile antennas, which will go into the 2 slots labeled mobile here. This is one. There we go. The other mobile antenna. Perfect, there you go. So that's going to be for our LTE. Wi-Fi, not really going to be using it, but it's always good to install these antennas. And what I mean by that is you typically don't want to have a transmitter going without having an antenna plugged in, so you know the Wi-Fi will turn on this thing, so you're going to want this attached. Not really going to cause a problem with this kind of stuff, but it's always good to have the antenna plugged in. There you go, this is a pretty typical looking 2.4 gigahertz Wi-Fi antenna. And just like that, we have our failover modem all physically put together. Next step is I actually have to go to Waterloo because I'm not there right now where all the servers are, and we'll get this thing set up. Now I know some of you are probably interested in what's inside this modem, so I just took out the 2 screws, and this is it. This is basically what's inside the modem. At the top we have a Quectel EC25 AF modem. What's kind of cool about this thing is it's basically its own little mini system on a module, since it contains an entire Qualcomm CPU, and actually I think runs essentially like a really small version of Android, or at least its firmware somewhat resembles Android, which makes sense. That's where all the work is going to be going for these kinds of modems. Of course, these are our antenna ports, and it's kind of interesting how that coaxial part of the connector is sort of soldered on. Go macro mode on, there we go. You can kind of see how it's just sitting there with some solder. Of course, if we flip this board around, this is the main part of the router. There's your MediaTek MIP CPU, MT7628NN, and of course the SIM module itself, and of course your Ethernet and its electronics. So there you go, that's the inside. Pretty simple device, but looks well made. Also, just on the side, the Quectel EC25 modem that's in here is actually pretty similar to the modem that's in the PinePhone. So I have my PinePhone here, back's removed, and if you look, there you go. There's an EG25, which is, yeah, pretty similar, both Cat4 modems. They have probably, honestly, the identical Qualcomm chip in there, and most likely use the same driver support in Linux, so that's just kind of cool. Alright, so we're here in the basement in Waterloo. These are the servers, if you have not met them yet. And yeah, pretty much everything is set up and working. I mean, you can see the precariously, this whole thing is kind of a cable management disaster. Don't worry about it. I have plans to fix it someday, probably. Anyway, the Ethernet cable here is precariously placed, and the RUT is sitting here. And actually, surprisingly, despite the fact that we are underground, and if you're wondering, that is a GPS antenna taped to the window there for there's the Sineware time server. Where was I? Right. Despite the fact that we're in a basement, we do actually get LTE coverage, and see, we get 3 bars of, well, I guess 3 LEDs of LTE, which is not amazing, but is good enough for now. If eventually I want to get a longer Ethernet cable, one, because this is funny but not ideal. I mean, probably just tape it to the window like the GPS antenna up there. The reason I'm not just putting it up somewhere else in the house, I mean, I could do that, but we have a UPS here, so I prefer it to be down here where it's, plugged into, there you go, plugged into backup power. But anyway, it works. Basically, we have MWAN 3 set up on this is the router, and removed this this is ETH4, removed that out of the LAN group, and set it up as another WAN. And yeah, it totally works. I'm not gonna do it now, but I can unplug the Ethernet. It'll keep working. Actually, in fact, you don't even need MWAN 3 if you're just worried about like the interface going offline, and you can just have 2 WAN interfaces with multiple metrics. But MWAN 3 has the functionality of pinging an external server to mark interfaces down. In any case, I will be demoing that. But yeah, that works. We now have redundant networks, because this thing is very bad. Bad modem. Cable sucks. I wish we got fiber here. All right, now it's time for the moment you've all been waiting for, probably. That is actually seeing this whole redundant WAN in action. So we have a ping going. Note the latencies, we're on Wi-Fi. Just about 20 milliseconds-ish. And so theoretically, I should just be able to come over here and, well, unplug the internet. So hopefully anyone using Sineware stuff is, well, the service is about to get slower. But there you go, that's disconnected. And you can trust me that that cable plugs into the, anyway. And there we go, we got one missed ping, but that is it. Everything else, it's still going. You can tell we're on the LTE because the, well, the latency's up, and, well, here we go. Let's plug the modem back in. There you go, it's been plugged back in, and theoretically, once we get an IP, and there we go, we see the pings go back down, so works great. Well, that's not actually a demo of M1 that's just a demo of metrics, but yeah. All right, and now for the second demo, which is the more interesting demo, which is bringing down the modem, but unplugging the coax, but not actually unplugging the interface. So we're gonna see M1 in action because the pings will fail internally, and then it'll switch over the interface. This one we'll see take a little bit longer. We should see some dropped packets. Or we should see more drop packets as, you know, it has to mark the interface as bad. Because of course, when these modems go offline, typically the LAN interfaces are still gonna, you know, physically stay up. So here we go, time to unplug the modem. And there we go, coax, you can see it has been physically unplugged and the modem is unhappy. If we go over to our pings, we can see that pings have stopped. And so it'll now take probably, I don't know, about 10 seconds for the pings to come back up. So I'll cut to that when it happens. All right, and there we go. So after some destination host unreachables, I just restarted the ping. And yeah, there you go, works. Once again, and you can tell we're on the data because of the higher latency. So there you go, the interface up, but bad. And in fact, if we switch over to OpenWRT over here, we can see how it's marked the WAN and WAN 6 interfaces as bad. Fallback is online, and that's exactly what we're using. So perfect, this works, great. And of course, hopefully, somewhat seamless. The connections will freeze when you connect to Sineware services when this situation happens. Also, I should probably plug the coax back in. But yeah, because all of this is connected through WireGuard to an edge in the cloud, that connection always stays up. So your TCP connections and stuff going over WireGuard are going to always stay online. It'll just temporarily freeze while this failover happens. But yeah, some configuration probably still to do to make this a little bit faster in terms of just messing with the, you know, the ping settings. And so yes, the setup has gotten a little bit more reliable, hopefully. So some of you are probably wondering how this actually works on the OpenWRT side, and it's basically all just done by this package called M1 which manages multiple interfaces, determining if they're up or down based on some criteria, typically pinging a server, and then setting up the routing tables to actually route traffic to the interfaces that are actually working correctly. So if we look here on the multi-WAN manager, we have a couple of interfaces. WAN and WAN 6 are the cable modem, the main internet connection, the IPv4 and IPv6. One of the weird quirks of M1 is you have to define IPv4 and IPv6 policies separately. Because our modem is IPv4 only, that's why there's only a single interface. This is the actual LTE modem right here. Here we can see how this is actually all configured in terms of the tracking for the interface. So you can see a couple of IPs set up here. We have Cloudflare and I believe OpenDNS. These are the servers that the router will ping to determine if an interface is actually up or down. There's a couple other options here, and all of this is basically just configuring the behavior of the tracking. So reliability is how many IPs of this list need to be up, the number of pings, the timeouts, etc. And there's some options here that I've set that basically flush routing tables when the interface comes up and down. This is important for keeping WireGuard working correctly. The member tab, basically it maps WAN interfaces to internal MWAN objects, and they define parameters, the metric and weight, which are used in the algorithms for the actual policies that you set up in the next tab. This is the real kind of meat of the fallback mechanism. If we head into our WAN fallback, what this does is basically define the members, which then of course are referenced to the physical interfaces. This defines the policy. So basically, if WAN goes offline, it'll fall back to WAN fallback or vice versa. And as a last resort, it'll just reject packets. And of course, there's also an accompanying one for IPv6, although in this case, there is no other member inside this policy. Rules determine what traffic actually is affected by the fallback. So for example, you can only have specific subnets go through this whole fallback mechanism. For example, if you have an internal LAN
And a server network like I have, I could, for example, restrict it so only the servers experience this fallback network, and other people in the house, if the internet goes down, the internet goes down. There's also some interesting things with DNS, with these IP set rules. You can have, like, I think, specific websites fallback. You can get pretty crazy with this. In our case, we just have all the traffic. We just have a 0 subnet set up for IPv4 and IPv6, and they get assigned to the IPv4 and IPv6 policies. Finally, there's this notify tab, which is pretty interesting. Basically, it's just a bash script that runs whenever any M1 event happens, as you can see described here. Anytime an interface goes up, down, is connected or disconnected, which is referring to the actual tracking. In my case, I actually have this set up with a Discord webhook. So whenever the internet goes down, I'll get notified on a Discord channel, which you can actually join the Sineware Discord. Link will be in the description. And I have it here. So anytime there's an IF update, which basically means that anytime there's some update to an interface, it'll post a webhook to Discord with this message telling me what interface, what physical device, and what the actual action, whether it was up, down, connected, etc. This part of the script restarts WireGuard anytime an action happens on multi-WAN. For example, if an interface goes up or an interface goes down. The reason we need this is WireGuard sets up its own routing table information and all of that kind of stuff. So we just restart the interface so that anytime there is a change in the routing coming from multi-WAN, when WireGuard comes back up, it'll reestablish a connection to the cloud VM and everything will be happy. So yeah, that's the multi-WAN setup, and it's a little bit annoying to actually figure out how to use it, how to configure everything properly. It definitely took a lot of tweaking to get it to work properly, and it's still kind of weird. There's been at least one instance where I've had multi-WAN, I think it's stuck thinking an interface was down, the main WAN interface, even though it was up, and I had to restart the modem. So there's probably still a little bit of tweaking left to do, but it works for the most part, and it's been fairly reliable, especially given the fact that the internet's not super stable on cable. So yeah, it's not bad. Definitely read the docs thoroughly, and you can more or less figure out how to set it up. Also, I realize I haven't actually given a tour of all of this on video yet. You've probably seen the picture on the Sineware website, but I guess, we might as well just kind of go through it. We have two 1U servers here. This bottom one is an HP, slightly older HP, as you can tell by the Xeon logo there. This is running Proxmox and has just a bunch of internal utilities, including x86 build server for Pro Linux, among some other things. This is Suzumiya server. Here we have Mau server. This is the latest addition actually to the stack. It really is not doing much of anything yet. So it's running, I think, Alma Linux I installed on here. And it's running the MRT proxy. That's basically all this is doing. At some point, this will do something else. Also, I realized I think this drive has failed. So that's fun. I did not notice that. Well, thankfully, this is not actually doing anything. And I wouldn't use these hard drives anyway. So, and then this is all of its storage is on the network. It's on the ZFS, which we'll get to in a second. This is Fern server. Fern server is the remnants of my brother's old PC. There's a Ryzen 3 in there, put into a new case, and running a Tesla P40. This is a somewhat older Pascal generation NVIDIA card, and I use this for some LLM stuff. It's basically running Olama. This is running my internal log stream server, and if you use Dr. Smoothie on the EspiDev Things Discord channel, Discord server, I should say, Dr. Smoothie's running off of this, so that's pretty sick. We have a little 3D printed fan bracket with two Noctua fans on there. That's cooling this GPU, because if you look under the bottom, you can't really see, but there's no fans. This is a flow-through design. It's meant to go to servers. Except it's in this, honestly, pretty nice deep cool case, which, by the way, love this case. It has a headphone holder. That's great. It also has a little shark fin. This is the UPS. It's a 1500 BA UPS. Works great. Trying to display here, you can see we're pulling on idle, it's running everything. About 550 watts, not bad. This is Yoimiya server. This is the Sineware server. Pretty much everything is running on here. The Mastodon's running on here, the Matrix server's running on here. And this is, of course, the most powerful server. I forgot exactly the Xeon that's in here. I'll put it up on screen, but there's a Xeon in there, 128 gigs of RAM in there. On the bottom, there's a couple of WD red hard drives that are in a ZFS array. So this is really the D server. Also, it's running one of these Chinese reproduction motherboards, which is really nice. Basically, old servers and stuff, they have proprietary form factor motherboards. The chipsets and sockets get harvested off of those and then get rebuilt into standard ATX motherboards with nice features like NVMe. You can actually see an NVMe SSD in there. So that's pretty cool. That was just straight off AliExpress. So yeah, that's the Yoimiya server. This is Hoshino server, which is for internal services. The main thing this is running is our log stream server. So syslogs from everything gets collected up in here. And of course the text embedding is happening on Fern server. And this just has a
like a 1 terabyte NVMe inside for storage. This is RAM server. RAM server has an Athlon 64. So not a very powerful server, also only like 4 gigs of RAM. This is just running some random stuff. Dr. Smoothie is running on here. The Discord web pages service is running on here. Basically, again, not super critical services, it's just a machine I have lying around. In fact, I haven't even upgraded the hard. This is still running like a 320 gig hard drive, no redundancy, so that's fun. Up here we have Time Server, which, yeah, that's its name. It's Time Server. Time Server is a Raspberry Pi 3 with, if you look underneath, a little GPS module and a small RTC on top with this ER2032 as well. Can I get a better angle on that? Not really. Oh, you can see the blinking light. That is the PPS, or pulse per second, coming off of the, well, not coming off the antenna literally, but you know, the antenna is picking up GPS signals. And if you don't know, GPS, very popular for positioning, but also in enterprise environments and scientific environments, because the way GPS works is by using timing between satellites and you to determine where you are, and that requires very precise timing. And so all GPS satellites have atomic clocks on board, and so you can actually just use GPS as a really accurate time source. So this is synchronizing time for everything. We get super accurate, like nanosecond accuracy with the Kenoi server running on there, so that's super cool. This is Megabean server. Megabean server is a Pentium 4, and it is off. This was used for some free PBX experimenting I did at one point, and along with the Cisco phone, which is a little Cisco IP phone. Both of these are not functional. I mean, Megabean server works, but it's off because I stopped with that. And the Cisco IP phone has been sitting there. One day I might do something interesting with that. Back here is Hayasaka server. Hayasaka server is actually running on it again. Redundant SSD storage. These are really nice, these little StarTech adapters. They take M.2 SATA SSDs. There's two of them in there. Probably pop up a picture if I can find one when I was setting this up. And this is great because this is just running in RAID 0, so nice reliable storage for this Raspberry Pi is a Raspberry Pi 4, 8 gig. This is running Nginx. And it also had some other, this was the first server in this whole thing. Nowadays, just relegated to running Nginx. At one point was doing things like ARM64 builds of Pro Linux, among some other things. Back here, this Frontier Communications, probably questioning why I have a Frontier Communications box, given the fact that I'm not in the US. Bought those off eBay. These are Mocha adapters. Really nice. This house does not have Ethernet run through the walls, but it does have coax running to a couple places, well, in this case 2. And what's great about coax with Mocha is I can run a multi-gigabit network. All of these are specifically just gigabit. But you can actually run multi-gigabit Ethernet over coax. And so those would open the closet. I'm too lazy, those just go into a little splitter. And so yeah, that allows us to get Ethernet throughout the house. Very nice. This is the Rogers modem. I hate this thing. It sucks. It's cable modem, what can you do? There's no fiber here, sadly, or it's not yet. So this is the best we can do. This is Lena server. This is an M2 Mac Mini, 8 gig, 256 gig storage, which is the base model M2 Mac Mini. This is our main ARM64 build node. Works great, super fast, love this thing. Plugged in with a separate NVMe SSD. There's a 1 terabyte in there, I believe, for more storage, because it's 256 gig, not a lot of storage. This thing is also pretty nice. Thunderbolt does not work on Asahi Linux yet, but USB 3.2, I believe? Some form of USB. Fast enough, and the Realtek chip in this thing I flashed with the latest firmware, something you can definitely look into if you have, these kind of generic, well, I guess it's not particularly generic, Snapdragon isn't. But yeah, if you have one of these, you can look into, you can usually flash generic, Realtek or whatever firmware onto these and get a bunch of fixes, because especially the UASP implementations are typically not great, especially for some of the older firmwares, so that's nice. This is the Unify CloudKey Gen 2 Plus. This is just running the Unify network. You'll see that, get to that in a second. And our cameras, which you can see, it's like through some information. Speaking of Unify main, this is our kind of our core switch. It's some switch that I don't quite remember the name, and man, this is this is a shot. You can even see I got a couple of SFP to Ethernet adapters to pull in some more Ethernets. Above that is just a generic unmanaged Netgear. There we go. Netgear switch. And above that, a TP-Link smart switch. And finally, the Omada ER605. That is our main OpenWRT router. So yeah, that is the Sineware stack, and that's my brother's laptop that I stole for this demo. But yeah, that's it. That's the that's too much. There we go. That is the current Sineware stack. It will presumably continue to evolve and grow. And if you use anything, our Mastodon, our Matrix server, Pro Linux cloud stuff, when that eventually drops, it's being powered by all of this. And so that's either a
Plus, because you're like me and you're like, wow, that's very cool. Or you are very concerned because none of this is even vaguely compliant or enterprise, besides maybe like 2 of the one used servers over there. But if you think this is cool, then you are the right customer for Sineware. And there we go, there's a logo. So yes, technically off topic for this video, but I thought I might as well shove this whole section in here. Anyway, that's pretty much it for this video. It's time to switch hands. Hello. Hope you guys enjoyed it, setting up multi-WAN, getting a tour of the server. Haven't uploaded something in a long time. I recorded a bunch of videos, or like these parts of videos. I never ended up finishing it. I might also have some bonus stuff to add to the end of this. Okay, so a quick update to the whole situation. Previously, we had the RUT installed in the basement. That was working. We actually got a signal down there, but I don't know if I've already mentioned it in a previous clip. We were on the roaming network for Fizz, so basically we were not actually connected to a Fizz mobile cell tower. We were on probably like Rogers or something. So after a little bit of research, great little website here, the whatever that is, I'll put the link in the description if I remember to. It's a really nice little website that'll tell you actually where all the cell towers are. And so I can actually, I can look and see what our nearest cell towers, these white ones, are Freedom Mobile. So, since I'm here around the University of Waterloo, this one's quite far. This one's a little bit closer to us. And so I was like, all right, I'm gonna bring the RUT upstairs into a room facing that direction. And if we go over there, here we go, here's the RUT. It's facing a wall. There's the outside world. I don't know if I'm gonna end up taping the RUT to the window or something, because technically this is just facing metal since the siding of the house, but I'll mess with the positioning. But anyway, the way this is gonna work is we have the RUT Ethernet plugged into a switch, and then that goes back to my room, into a Mocha adapter, and then that goes coaxial down to the basement to the servers. The idea is I'll just set up a VLAN that essentially moves all the traffic coming out of this cable, which is what's connected to the RUT, backhaul it back downstairs, and then hopefully we will actually be able to get essentially a native Ethernet link between the two. So basically the way this is set up on the TP-Link side is port 8 is untagged, so Ethernet frames, packets coming into this port, which is where the RUT is connected to, will get thrown onto this VLAN. Then port 1, which is the Ethernet cable coming back from the room, is tagged. So this will end up into this Ubiquiti switch, which will pick up the tagged port, bring it all the way down to the basement, where we can then configure the other Ubiquiti switch down there to have a corresponding untagged port on VLAN 100 that we can just connect into the router. Also, technically, I can create a VLAN network ID on the actual OpenWRT router, but it's honestly probably just easier to use a physical port and just Ethernet hook them up. So we are getting quite busy here. I mean, we have another TP-Link smart switch we could use also, that works, but we'll probably squeeze our cable right there. We have one unused port on the Unify side, that's port 5. So we'll set that to be an untagged port. And then this is the Ethernet cable I used to go to the RUT. I'll probably get something shorter, but this will just plug in to the switch, and so this will be our fallback connection. All right, so there's port 5. Currently it's just on the default network, which is the native untagged port, but we should just be able to change that now to RUT link VLAN. Any frames going into that port will get tagged with VLAN 100. And they should reach the switch here, and then the switch at the TP-Link side, where it'll then get untagged and reach the RUT, hopefully. The saga continues. Yes, the RUT situation is now back in my room here. We're not quite done yet. These little antennas, they work pretty well, but the cell tower is a decent distance away from here. So the actual speeds coming off of this thing currently, kind of no matter where I position it, is not great. Like half a meg up, which is fine. It works, but is not, not ideal. So I bought these antennas, which were very cheap on Amazon and probably not that great. So we'll see if they actually improve the situation somewhat. Here's them sort of side by side with the built-in antenna. From what I heard on some of the reviews, some people were saying it's great, some people were saying it's bad. Some people said it increased the signal strength, but actually lowered their download speeds. I guess we'll find out. One person correctly, I think, noted is that this cable is very long and very thin, so I suspect a lot of the losses are going to be in here. So anyway, we're gonna plug these in and see if this actually helps. Okay, the antennas have been screwed in, and their cables just sort of strewn across. And I've just put them up at the windows. I'll Spider, say hi. I've just taped them down for now because these are very top heavy and very floppy. I think the bases are magnetic, but this is wood, and anyway, they came with
actual 3M pads. I'll use that to permanently stick them down later. But this will be good enough for testing, just positioning, you know, how far do I want these apart. This is a category 4 LTE modem, so as far as I know, it uses 2 spatial streams of both antennas for downlink, but for uplink it only uses 1. So the position probably doesn't matter too much, but you know, maybe this side of the window versus that side of the window, or who knows. I don't know if I mentioned this before, this house has siding. You can't see it from here, but this house has siding, so it's all metal on the other side of this. So the windows are really the best place, and the LTE antenna's in that vague direction. So anyway, let's flip the RUT on and compare the results. Okay, so kind of interesting results here. The download speed is actually pretty considerably faster, like quite a bit faster. It's almost at 10 megabits per second, which I mean also is not amazing, but before it was quite a bit lower. The upload speed though has, I think, marginally improved a little bit. It actually started out pretty good and it dropped a little bit. Not amazing, 730 kilobits per second. Category 4 LTE theoretically can go up to 50. So, you know, I'd hope more like 10. 10 would be acceptable. This is not amazing. I'm gonna mess with the positioning of the antennas a little bit. But this is still an improvement, so I'll take it. All right, they've been stuck down with the little 3M pads. This is just the cover. Those are stuck down pretty good. And the results are the same as when they were taped down, unsurprisingly. We're looking at around, it did drop a little bit at the end, but we're looking at around 1 megabit up and 10 megabit down, which, you know what, will be good enough for minor internet outages. So there we go. Also, one other thing I set up, I think I probably mentioned this early in the video. This video, if you haven't noticed, has spanned over, I think, at least a couple weeks now, just because, you know, I've been working on it on and off. But I did, if we go over to the VPN settings over here, I did just quickly set up a WireGuard from this modem directly. This way I can remote manage it, and this just connects to a cloud VM. So there we go. That's pretty much it. I don't know where this segment's getting slotted into the video. There's something coming up after this. Be sure to hit that like button.
So it's been about a month since that last clip, and now I'm in Singapore. Yeah, that's right. And this is actually related to the video because this was one of the reasons I wanted to make sure I got this WAN fallback setup all working since I was going to, and now I'm currently in a 4-month academic exchange term. And so, of course, I wanted to make sure that the Sineware services were more reliable since I would be away. Of course, I have my brother and friends who can do server debugging in person, but either way, we definitely needed redundant internet, and this would have been pushed back 4 months had I not gotten it done anyway. The fallback WAN setup, that is. But yeah, that's basically it. I hope you enjoyed the video. It's kind of a mess since I was recording this while also trying to figure everything out. But if you made it this far, I assume you'd be the kind of person to subscribe to the channel, since you'd probably enjoy these kinds of videos that I make, apparently like once every year. Anyway, I'll see you all next time.